This traditional idea that eating lots of carbs, that spikes lots of insulin, and then that causes insulin resistance. In and of itself, I don't think that that's actually what's happening. As people become metabolically unhealthy, or they become insulin resistant, there does seem to be this link to cognitive decline. There are studies that look at cognitive decline over time, and in people who have normal blood sugar control, so they have an HbA1c below 5.7, then they looked at people with pre-diabetes above 5.7 up to 6.5. They had faster cognitive decline, and then it was even faster in people who had type 2 diabetes. When a certain part of the brain becomes active, it asks for more energy. There's this thing called neurovascular coupling. And then that part of the brain delivers more blood flow. It starts to divert blood flow to that area. If you don't have healthy blood vessels, that can't happen. And we know that endothelial function and blood vessel function declines as we become less metabolically flexible over time. Most people who have Alzheimer's disease also have vascular disease in the brain. For most people, it's not separate entities. It's part of the same disease process. The nutrients is the thing that I focus on the most. If you get the nutrients, it doesn't really matter where the nutrients come from. Then we don't have to argue about keto versus plant-based versus paleo versus carnivore. Like, just get the nutrients that you need, and that's it.
Tommy, you are an expert in many different areas, but I want to start our conversation talking about brain health.
All right.
And you make this comparison between the brain and muscle. So let's connect the dots there.
So one of the reasons why I do that is because I'm a bit of a sort of self-confessed meathead. I like to lift weights, and therefore it makes sense to me to think about the brain in a similar way as when I go and lift things in the gym. But if you look at how the brain first constructs itself, sort of first develops in kids and early adulthood, and that's that's where a lot of my research is in the developing brain, as well as in the older brain, looking at sort of cognitive decline and dementia. When you look at what drives the development of the brain in the first place, it's all to do with the stimuli and the inputs that brain gets, right? And that's learning skills, learning languages, learning social interaction. These are what drive the structure and the function of the brain, assuming that we have sort of the resources to respond, which is where nutrition and these other things become important. But the primary driver of brain function is the stimulus that brain gets, is how that brain is used. And so that essentially is identical to, if you want to get bigger and stronger in the gym, yes, your sleep is important. Yes, your nutrition is important. Getting enough protein is important. But if you don't do bicep curls, your biceps don't get bigger. And the brain is essentially the same. If we don't provide it stimulus and inputs that drive new function and new structure, then we don't improve the structure and function of those parts of the brain. And those other things become important again, right? Sleep is critical, nutrition is critical. But really, how we use our brains is the primary driver of how our brains then function.
Well, let's get into the specifics there. When it comes to these inputs, what are they? And what's the right dose?
The best inputs that our brain can get really are inputs that are sort of baked into human evolution, if that makes sense. So I kind of suggested a few of them, which is, learning motor skills, right? That's, you can kind of see as a kid develops, they work really hard to stand and then to walk or to reach and to grip. And then as they get older, learning to climb and jump and run and that kind of stuff. That is a critical input to several parts of the brain, and not just the motor cortex that controls movement, but also several parts related to decision making and risk assessment, because that's a big part of that. And then language development is a big part of that too. So obviously there's the first language that you learn, but we know that people who grow up learning two languages, so particularly people who are fluently bilingual, and I'm not saying that everybody needs to go away and worry because they're not fluently bilingual, but what's interesting is that if you are fluently bilingual, those people tend to have better executive control. They're better at decision making and deciding what to do because their brain is constantly working at trying to figure out which language they're currently operating in. So because they become better at saying, this is the language I'm working in, that translates over to, I'm actually better at deciding what to do in the moment. And you can gain some of that by learning a second language, even as an adult. So there are studies in people in their 60s and 70s who do Duolingo, and it improves aspects of their executive function. So even just that small stimulus is really important. Then another big part is social connection. So we know that the way that we interact with other people is a primary driver of brain function. And particularly as we get older, social isolation and poor social connection are significant contributors to cognitive decline and dementia, because we're not having to engage those parts of our brain that, again, language, but also just like how do you respond to somebody, the process of empathy and understanding and listening. These are really complex skills that are sort of core parts of what it means to be human. And I think those are really the stimuli that the brain is best adapted to learning from, and that seem to support brain structure and function. And so some of them, you asked about the right dose, is kind of split up into two things. So one is maintaining the parts of the brain and the skills that we have. It's the same as maintaining the strength and the muscle mass that you currently have, right? You need some sort of maintenance dose. And so for social interaction and physical activity, it's like, ideally you see somebody and you talk to them and interact with them every day, right? Ideally multiple people. And then the other part is, well, what about learning new skills? If we're trying to develop a new thing, what does that dose look like? And then, there are studies on learning musical instruments. There are studies on learning languages. There are studies on juggling. When we're thinking about physical activity, like coordinative exercises, things that require us to respond to the environment, like ball sports and team sports, they seem to have a bigger effect than like going jogging. But jogging is great too, don't get me wrong. But this is more complex. And then it's something like, 2 or 3 times a week, sort of 30 to 60 minutes, something like that, seems to be like a reasonable dose. And the reason for that is because particularly when we're learning something new, it should be hard work, right? We're making mistakes. We're having to really focus. Focusing is difficult sometimes, right? It takes up a lot of resources and cognitive resources to do it. So something like that, 2 or 3 times a week, really working right at the edge of your skill on some new thing that is on top of the sort of like the maintenance stuff. That's where we can really start to push and build function.
Tommy, do you personally have anything you're working on now in that new skill realm?
There are a few things that I'm working on right now. So in the last couple of years, I've done a lot more learning how to code. So traditionally that wasn't part of my job, but both coding in R, which is we use for statistics, and then Python for some other things. There's some nice studies that show that learning to code activates similar parts of the brain as learning a language. It's not quite the same, but it's similar. Then usually I'm working on some kind of balance or coordination thing in the gym when I work out. And right now I'm also starting to write a book, and sort of I'm used to writing for an academic audience, right? Dry scientific papers that 7 people will read. But you're trying to write something that goes out to a general audience that everybody can understand. That's a skill in itself. So those are probably like 3 things that I'm working on right now to kind of build my own skill set.
That's great. And you talked about the aspect of the importance of having these social connections, which got me thinking about the difference between connecting like we are now with a screen versus in person. And more these days, we're connecting digitally like this. Is there any research showing the difference when it comes to brain health when we're connecting like this versus face-to-face?
Yeah, that's a great question. And something, there has been a lot of research, and a lot of it because, and you're probably not surprised, because of COVID, right? When how we connected with one another changed drastically and almost overnight. So there are 2 main takeaways. One is that if you're going to connect with somebody online, there is a hierarchy, which is like video calls, then voice calls, then text messages with loved ones and friends. And then just like way down at the bottom here is interacting with random people on Instagram. So you can kind of see that those first 2 or 3 can be beneficial, and that last one, particularly depending on your other context, can potentially be detrimental. And the second part of it is that if you're making a connection online and you're having an interaction online that you wouldn't have had otherwise, that's beneficial, right? It's very unlikely that you and I are going to be able to like regularly sit down and have a cup of coffee together, but we can meet online, right? So that's a net benefit. If we're meeting online because we're instead of meeting in person, that's a net negative. So if you're replacing in-person social interaction with virtual interaction, that seems to be a net negative. If you're increasing your social connection on top of what you already have, that's sort of beneficial, but you're getting more because you have access to more people through an online environment, there's probably a net positive.
Okay, so far we've been looking at this primarily from the lens of including things that are good for the brain, whether it be social connection or learning new skills. As we're talking about this digital age with all these different apps and ways of connecting and social media, we also need to look at it from what we're not taking in, like a lot of these things in the health realm.
Yeah.
So when it comes to brain health, how do we protect ourselves against this new digital world and social media and such?
When we think about the modern technological environment and our interactions with technology, in general, our response is to think it's probably going to be bad for us, right? And understandably so when it's sort of overtaken our lives in the way that it has. However, I think the most important thing is the greater context that you've just asked about. So I'll give you another example, which is playing video games. There's actually several studies that suggest that, particularly in people who don't have much experience playing video games, playing immersive, like 3D environment, sort of like explorational video games, and the one that actually I think has the most studies is Super Mario 3D World, where you're in this complex new environment. You know, you have to learn some new motor skills. You have to react and respond. That can increase some or improve some aspects of cognitive function. And so anytime you say that, everybody's like, but aren't video games bad for us? And it's a novel stimulus. And for that reason, if you play it in those kind of, chunks I talked about a few times a week, 30, 60 minutes, something like that, then you can increase the function of certain parts of the brain. Where it becomes a problem, and I think social media is the same, email and all those other things are the same, is when you're spending so much time doing that you're not sleeping properly, eating properly, going outside and doing physical activity, interacting with other real humans in real life. So I think it's much more to do with the other stuff. So then, anybody who I think talks sort of sensibly in this world. So a colleague of mine, we don't work together, but she works at the University of Washington, where I work. Katie Davis, she wrote a book called Technology's Child, like talking about particularly technology in children. And it's just all about control, like you having control over your interactions with technology, right? So it's not controlling you through notifications and constantly demanding your attention and your time. If you can then have very defined interactions with it and make sure that you're doing all these other things, there's a number of reasons why it could be beneficial. You can have more online connection. You can have a new cognitive stimulus through something like a video game. But in order to then respond to that properly and overall have a healthier and happier brain, you sleep and nutrition and physical activity are going to be really critical as part of that.
Well, let's move into some of these other ones you just mentioned. Sleep, physical activity, nutrition. Let's go to sleep first and talk about why, specifically when it comes to brain health, we need to optimize that.
The way that I think about this is that if stimulus is the primary driver of cognitive function, which I believe it is in many ways, then the time that the brain adapts and responds to that stimulus is during sleep primarily. I mean, also like to a lesser extent during periods where we're just not doing things with our brain. So there are examples with meditation and mindfulness, or just sitting there being bored, when you're sort of the cognitive load is much lower. that's when the brain starts to adapt and respond. So it's the same as, if I'm going to go to the gym, I don't get stronger in the gym. I get stronger when I recover afterwards, right? And when I sleep afterwards. And the brain is essentially the same. So during sleep is when the brain starts to decide the final connections that are made, the synapses that are either developed or the synapses that are removed. And it's a dynamic process. We're constantly making and removing synapses in the brain, like all of us, all the time. But when we sleep, based on those new synapses or the synapses we've decided to keep from a certain stimulus, sleep is when that's cemented. It's like this is now the pattern of connection that we have based on this stimulus, and then that's what helps us retain that memory or that new skill that we've developed. At the same time, sleep, we've sort of increasingly been finding, and by we, I mean like the research community in general, is the time when we do all these other like repair and maintenance processes in the brain. So when we stimulate the brain, just like when we stimulate our muscles, we upregulate things like autophagy, the recycling of proteins, sort of getting rid of junky stuff that isn't really working properly. That continues and is sort of finished during sleep, as is all the waste clearance that we get. So there's something called the glymphatic system, which is essentially just like all the fluid that flows through the brain around all the cells, and it's driven by the pulses of your vascular system, of like the blood vessels in the brain. That kind of like shifts. It's one of the and then when we breathe as well, helps shift this fluid through the brain. But that fluid expands, and sort of the flow increases when we're asleep. So it's kind of like, the pressure washer kind of like hosing down the concrete pad of your driveway to kind of clean everything out. That happens during sleep. So all the proteins and other metabolites and things that build up when our brains are working hard during the day, that gets cleared out. So all of that responding to and processing all the stuff that we did during the day, that gets consolidated when we sleep, as well as clearing everything out, and then we reset a lot of the systems in the brain so that we can then take in a whole bunch of new experiences the next day. And that's a critical part. But then sort of more, right, that's the kind of the mechanistic and biological explanation. But if we think about what's really important, or some of the important aspects of our brain, it includes our ability to focus and engage. And we know that drops off when we're sleep deprived. So if you don't sleep well one night, or especially several nights in a row. Actually, our brains are pretty good at dealing with a night or two of poor sleep. We tend to like catastrophize when we don't sleep. Well, oh my God, I didn't sleep. My brain's going to be terrible today. But actually, that's usually not true. And it's more driven by the fact that we think we're going to perform poorly because we didn't sleep, whereas actually our brains would have been fine. But over long periods of time, sleep deprivation does decrease our ability to focus and pay attention. But it also decreases our ability to connect with other people. We become less empathetic. We're more likely to respond negatively to something or imagine that somebody else is doing something for a negative reason. And that then impairs our social connection that we already talked about, why that was so important. So for both like the biological as well as the sociological reasons, like sleep is this really critical input to long-term brain health.
And for you specifically, when you're leading up to sleep at night, what are the things you do to enhance that?
My days are fairly well structured. I'm lucky that gets to be the case. It's not the case for everybody. But I usually sort of work backwards. So I know when I'm going to wake up. At 6 a.m., the dogs want to wake up and go outside to pee. Like rain or shine every day. So I know I'm going to wake up at 6 a.m. If I want to sleep for sort of 7 to 8 hours, which is a good range for like sort of if we had to be like an average amount of sleep that people should get, it's about 7 hours. That the range is like 6 to 10 for one individual to another. So don't take 7 as like a thing you have to hit. But if I want to get like 7 to 8 hours, then I need to make sure that I have 8 to 9 hours of sleep opportunity, right? So I need to be in bed 9 hours before I'm going to wake up. So I need to be in bed at 9, which is generally pretty close to how things go. And then in the run up to that, there's sort of like a winding down period. Over an hour or two, lights get turned off. There's like not doing work on computers or phones. My wife likes, gets like a cup of herbal tea before bed. That's part of the wind down routine. I like blue light blocking glasses. It's probably at this point just like placebo effect. It's like the glasses go on and my brain's like, it's bedtime. I've kind of conditioned myself to half an hour before my brain knows it's bedtime. Of course, like bright lights and these other things can suppress melatonin production, that can delay sleep onset. But some of it's also just like building of the routine. And then sort of like the final bit, particularly for the sleep preparation, is that some people find they don't sleep as well if they've eaten a very heavy meal or they've eaten a meal right before bed, or if they've exercised right before bed. So I exercise at least 4 or 5 hours before bed, and I eat dinner like 3 hours before I go to bed. Other people, particularly if they're very high volume athletes, I've done a lot of work with professional athletes. If they need a very high volume of calories, then they may, right, if they eat their last meal 3 hours before bed, then they're hungry at bedtime and then they sleep worse. So they might need a snack before bed. So it's just figuring out what you need and then having that kind of run-in period.
So you talked about the blue light blocking glasses. On the other end of the spectrum, when you get up in the morning with the dogs, do you try and get light in the eyes to set your circadian rhythm?
Yes, as much as possible. That's not possible every morning. Just like if I immediately have to go into work, like some of the work I do is in the lab in the basement, and I'm in there at 6 a.m. until like 1 p.m. or something. If that's the case, I'm not going to worry about it. It is what it is. But on the days when I can, like right now we had a nice sunny day we're having a nice sunny day in Seattle. If, before we jumped on this podcast, it was about sort of 9 a.m. I took the dogs outside. We stood around, got some sun, and, as much as possible, trying to get bright light in the eyes in the morning to help set that rhythm, I think is important. But again, like I said, the circadian rhythm doesn't just come on one day at a time, right? You can sort of do things that you can do most days, and then if it doesn't happen on a given day, it's no big deal. You just sort of like, what you do most of the time is what makes the difference.
And just to clarify, we're not talking about going out and staring right at the sun.
No.
Just being out in the sunlight, and that light naturally is going to get in the eyes.
Mainly because the brightness of light that you get indoors, even on a cloudy day, doesn't match up to the light that you get outside. So even if it's cloudy in the middle of the morning, you're getting a lot more light than you think compared to just like being inside. So don't need to stare at the sun. It doesn't even need to be sunny. You can still have that effect.
Okay, let's come to the work piece. You quickly mentioned work there. When you have control, because of what you know about the brain, how do you set up your day to get the most out of your brain? Do you have certain blocks of time you like to work in, taking breaks, naps? Share how you become most productive and focused.
It's a great question because nowadays, most of us who are knowledge workers, right, our productivity comes from our brains, which is probably the majority of people in westernized society at this point. There's just this like continual onslaught of things that we're being asked to do, and often on somebody else's timescale and not our own, right? Your boss is like, you got to do this right now, and you get the email notification or the Slack notification or the Teams notification or whatever, and they continuously come in. That is pretty much the worst case scenario for actually being able to do any productive work. So sometimes you have to respond, of course, but a better way to do it, and this is what I do, is really break your day down into chunks of different kinds of work. So a nice example of this comes from a friend and colleague of mine, Dr. James Hewitt, and he talks about cognitive gears. So basically, there are 3 levels of work that your brain can do, approximately, like high gear, middle gear, low gear. Low gear is the rest and recovery. It's when we're not doing anything, sleep, an actual lunch break, going for a walk outside, whatever, just like something where you're not doing anything with your brain, including not switching from Instagram to email to whatever. What most of us spend our time doing is middle gear what he calls middle gear, which is task switching, quote unquote, multitasking. It's on a Zoom call while you're doing your email. It's trying to write an email while somebody else is messaging you on something else. It's picking up Instagram while, you're on a podcast. I'm obviously not doing that, but it's that kind of trying to do multiple things at the time and switching back and forth, and having to switch your attention because of somebody else's, intrusion on your attention with notifications and that kind of stuff. So of course you need to respond to email. You need to do this kind of work, but it's best to fit that into a time when your brain is going to be less likely to do really high quality deep work. And every individual has their certain ultradian or ultradian, depending on how you pronounce it, rhythm. So across a day, our energy levels naturally fluctuate every sort of 1 to 2 hours-ish. It may even be broader than that for some people. But you'll probably know there's some period of the time when your brain works best. This is the time I feel good, right? That's the time when notifications should be switched off, emails should be shut down, and just for an hour or two at least, right at the peak, you get stuff done. And when you can do that, everything else just becomes much, much simpler. Then after that, ideally, so that's your high gear work. That's what James would call your high gear work. Then, right, we talked about stimulus, hard work, using the brain. After that, it needs to recover. If you can get a lunch break or a walk or something after that, it doesn't have to be a lot, but just some time to, come back down and reset, that's great. And then, so I'm kind of giving you my version. In the morning is when I feel best. That's when I do my high quality work. I try not to have meetings. I try not to do other stuff. Try to write my book. And then after that, right, there's a bit of a break. I have some lunch, take the dogs for a walk, whatever. And then early afternoon, that's when, I get a little bit of my kind of less energy. It's not a slump, but it's just I'm less kind of really focused. So then that's when I'll clear out emails. That's when I'll address other stuff that just requires little bits of work here or there. It doesn't really require really focused attention. And then often people will get a second bump later in the afternoon, sometimes in the early evening. If you can take advantage of that without it negatively affecting your bedtime, that's fine too. But just think about matching the type of work that you're trying to do. And I'm kind of assuming two big buckets. One is focused work where you really need on your own to focus and get something done. And then there's all the other odds and jobs and emails and messages and that kind of stuff. And just align them to your periods of best attention and focus. And that'll be different for you than what it is for me. Just you'll know when you feel best to do that kind of work. And then you don't have to sacrifice anything in particular. You've just kind of aligned your time accordingly. And as much as you can, right, try not to get meetings and these other things. Meetings are great to go into your middle gear box, right? It doesn't require, it requires your attention, but it's not really deep focused thinking type work. So if you're able to do that, I think that's the best kind of setup to be as productive and least stressed about the work that you have to do in a given day.
For a situation where, say you didn't get a good sleep the night before, or you need to have this podcast recording or meeting at a time when you're not functioning highly, how do you feel about hacking that with nootropics, caffeine, and then talk about what you would use as better choices in that realm?
Sometimes when you have to perform in the moment, it's absolutely fine. If there's something that you can take or do that helps you do that, I think that's great. Relying on it consistently, I think, becomes more of a problem. And it's because, every nootropic out there, every stimulant out there, you increase performance in one aspect and then you usually decrease performance somewhere else. Now, nootropics are sold to us as being well, you improve everything and there's no downside. And it's just not true. I'm sorry. So there's when you look at things like the racetams and these other sort of classical nootropics, you often see an improvement in one aspect of function, but a decrease in another aspect. Now, if in the moment it helps you do the thing that you need to do and there's no downside because it doesn't help you to do the thing you don't need to do, fine. I have nothing against that. But probably the best example is caffeine or other stimulants. In general, like people who consume caffeine every day, as I do, first thing I do in the morning after I walk the dogs is I make my cup of coffee, is usually most of the benefit you're getting is just like a restoration of normal function, because you're overcoming the caffeine deficiency that you've hit at that part in the morning. And again, like, it's not a problem. That's what's happening. When you then use caffeine to increase function, and it's ergogenic, like it improves performance, particularly in non-complex skill sports. So you sprint faster, you lift heavier weights, right? You can work harder in the gym if you take a big fat dose of caffeine. That's pretty well understood. If you then look at cognitive functions, caffeine and most other stimulants, they've looked at things like methylphenidate, some of these other amphetamine type drugs that they use, that some people do absolutely benefit from if they have ADHD or related conditions. What they do is two things. They increase sort of the reactivity of the nervous system. So like your reaction time, which is a very, very simple cognitive function, that increases with caffeine and some of these other stimulants. But if you look at more complex functions like response inhibition, like which is like a quick decision-making thing, or working memory, actually they tend to get worse with those stimulants. So stimulants improve simple cognitive functions, but for complex cognitive functions, you become over aroused, right? You're sort of like, you can't fully engage in the process because you're kind of like, you're a bit too wired. The problem, and I think this is something that comes from a lot of the nootropics research, similarly, or these kind of supplements, is that you think you're performing better, but you're not. There's similar research in like creativity with cannabis. You think you're more creative, but when you do a task that requires creativity, and then people look at it, they're like, oh no, that's not very creative. So like you feel better, but you're not necessarily performing better. Now, again, that's not necessarily a bad thing. If you think that you perform better, sometimes you do perform better just because you think you're doing better. But just like all of this is a really long answer to your question to say that most of the time when we use these things, we feel better, but we're not like, if we could like objectively measure our performance, it's not necessarily that much improved. So if you're thinking about, right, you didn't sleep well and you need to do an exam, right, which is a very standard occurrence for students all around the world. Thinking about, there are other ways that you could boost your arousal. Like that's the problem, is you have an arousal deficit going into the exam because you didn't sleep properly. Caffeine is one way to do it. With like small amounts are great, or like your habitual amount is great. You kind of get up that deficit, over that deficit. When you're sleep deprived, you do have fewer dopamine receptors in some parts of the brain that gets restored by caffeine. So when you're sleep deprived, caffeine seems to be more beneficial than just at baseline. But there are other ways to do that. So exercise is a great way to do that. So something up to 20 minutes that's not exhausting, but like going for a jog, a brisk walk, even a couple of sprints, that kind of increases arousal. That's going to improve your ability to perform. Bright light is another one. So getting outside, getting sunlight in your eyes, the way we talked about it. You can also they've used light boxes. So, like a 10,000 lux SAD, seasonal affective disorder lamp that you can sort of like buy. If you can't get outside, you can use those. Cold will do it as well. Really like hyperventilatory breath work, that'll probably do it too. It's just anything that's going to get you going. It doesn't necessarily need to come in the form of a pill. That's going to then help you, particularly if you're sleep deprived and trying to perform, that's going to help you sort of make up the difference in the arousal that you get because you haven't slept properly.
Talk to the physiology. Somebody who has a bad night's sleep, whether it be staying up too late, young kids waking you up in the middle of the night, dogs need to pee, whatever it is. Talk about what changes happen in the brain in the morning, and then the physiology of caffeine. And then we can pivot into some other things and how that can help.
Sure. So I already I mentioned one, which is, so we're thinking about motivation and engagement, but also learning. Fluctuations in dopamine are critical in that. So sort of like motivation and engagement in something where we're going to learn something. And this is actually why social media is so engaging for us, is because humans are wired to learn from social contexts. So the opportunity to learn from like social information, which is what comes on social media, is right there. So that is automatically quite motivating to us. And then sort of like the variability in the reward we're going to get, right? How many likes we're going to get, how much interactions we're going to get with our posts. This is just like, this is absolutely the dopamine slot machine. And it's one of the reasons, because it's the social aspect that makes it so potentially rewarding to us. And so, but then the other side of dopamine that's really important for learning, and it's something that I didn't go into a lot of detail earlier, is that when we make mistakes, that is one of the biggest drivers for learning. And when we make a mistake, actually dopamine drops. So it's actually a dopamine drop that's important, that helps our brain learn something, because it's like, oh, I expected this thing to happen, and it didn't happen. And then that also drives learning. So it's not like we want to always find ways to have more dopamine. Sometimes like less dopamine is good, and making mistakes is actually really good for driving that process. But where this comes to sleep is that some parts of the brain, dopamine receptors are down-regulated when we're sleep deprived. So that's where, and that seems to be some of the part of where caffeine can overcome bits of sleep deprivation, is because it then upregulates, or it sort of normalizes or brings your dopamine receptors back to normal, so that you can kind of respond to these aspects of the environment in a normal way. The other part, which is sort of like the classical effect of caffeine, and is related to the dopamine aspect too, but sort of more broadly, is that when our brains are doing anything, when they're awake, they're producing metabolites due to the metabolism of just like doing their daily stuff. And one of the metabolites they produce is adenosine. And adenosine binds to receptors on other cells, and it decreases their metabolism, essentially. So adenosine is something that builds up during the day, and it's part of that switch over to sleep, as part of what we call sleep pressure. So just the process of being awake builds up metabolites like adenosine that help to then create the environment for sleep. So the next morning, if you haven't had a full night of sleep, you haven't been able to clear out all the stuff that accumulates, one of those things is adenosine, then you've still got some adenosine kicking around, and caffeine is an adenosine antagonist. It binds to the receptor for adenosine so that it can't bind to those cells and decrease their metabolism and function. So that's two ways that when you're sleep deprived, it affects the way your brain functions, and that caffeine can overcome that.
The adenosine piece was the part I was fishing for.
Yeah.
The part I'm familiar with.
Yeah.
When it comes to caffeine, specifically coffee in the morning, how do you feel about specifics of hacking that? I've heard different things like waiting a certain period of time once you get up to have a better effect of that caffeine. And I've also heard grinding the beans fresh makes a difference. So anything in those realms or other that we can use as hacks for our coffee or caffeine in the morning?
So I've heard that thing about delaying caffeine as well. Like some people are concerned about, well, they're like, well, when you first wake up, you're going to be awake anyway, so then you don't necessarily need the coffee. Other people have said that, right in the morning, your cortisol peak is high, and then like you add a bunch of stimulants on top of that, and that could maybe mess with your blood sugar. Like theoretically, that's possible. Like when you do drink coffee, in general, your caffeine does increase your blood sugar like a little bit. But I don't think that's a bad thing. It is what it is. There was a recent review paper that kind of dug into the literature on this idea. And basically, there's very little evidence that says that you should delay your caffeine intake. It's much more to do with what makes you feel like you can function at your best. So if you wake up in the morning and you can do a couple of hours of high quality work with no coffee, but then things start to drop, but you still need to work, right? Then maybe that's when you have your cup of coffee. If you wake up and you're sort of like bleary eyed and you can't really understand what's going on in the world, then maybe coffee first thing is going to help you there. So I think I would just time it time it to your natural rhythm so that you can take advantage, maybe if it gives you a little boost, but obviously make sure that it's not so late in the day that it then affects your sleep. So big doses of caffeine, particularly after around midday, tend to negatively affect sleep that night. So I would just do it based on your own personal preference. I don't think there's like an automatic hack in there. In terms of grinding the beans, so then there's also like the roasting of the beans. So darker roast coffees tend to have a slightly higher caffeine content on average. Like Arabica beans tend to have slightly lower caffeine content compared to Robusta beans. Like all of this is you're sort of welcome to tinker with, but I would kind of say it probably doesn't really matter that much. I grind my beans fresh every morning because I'm a bit of a coffee snob. So that's like part of my routine. But you can take instant coffee from Robusta beans and get 99.9, as long as you enjoy it and it does what you need it to do, that's fine too. Sorry, I don't have any hacks.
No, that was great. And I want to piggyback off of all this talk about sleep and sleep deprivation to segue into your favorite supplement, which is creatine.
Mm-hmm.
And there's a lot I want to get into here with you. Let's start off talking about that sleep deprivation piece, which to me seems like a newer piece to this. Typically, bodybuilders, for years have been using this to put on muscle mass and to have better workouts.
Yeah.
But let's just take it from the top. Sleep deprivation, what the research is showing, and then we'll go from there.
This idea of creatine being able to offset some of the effects of sleep deprivation, I think it's come to the public consciousness in the last year or so, because there was a paper that came out that specifically looked at this. What they did is they gave people creatine after a night of sleep deprivation compared to a placebo, and they saw a restoration of sort of like energetics in the brain with a brain scan. And so that's like very similar to this effect of caffeine, right? Where you give caffeine, you can offset some of the negative effects of adenosine that's built up, and you can maintain energy production in the brain. But there was actually a study several years ago that looked at this in rugby players, where they gave them either caffeine or creatine after a night of sleep deprivation, and compared to a placebo, like a low dose of, or like a standard kind of maintenance dose of creatine, like 5 to 10 grams, it had the same effect on maintaining. They did like rugby skills. They did a rugby skills session in these rugby players after sleep deprivation, and both creatine and caffeine had the same benefit compared to a placebo in terms of maintaining those skills after sleep deprivation. That study didn't get nearly as much press as this other one, but this other one, they gave a bigger dose. It was more like sort of 20 to 30 grams of creatine, and saw it sort of offset this negative effect of sleep deprivation. What I think a lot of people have talked about, but there hasn't necessarily been, is sort of like super anecdotal for a long time now, until we've sort of seen more of these studies around sleep deprivation, is that for some people, creatine can be quite stimulating, and not necessarily stimulating in the same way as if you had like a whole bunch of espressos, but it can sort of increase alertness slightly. I think the mechanism is still a little bit debated. Like nobody really knows exactly what it's doing. It's obviously creatine is needed by cells to provide a buffer of energy sources, like a buffer of ATP in the phosphocreatine system. So it could partly be that. But for me, for a long time, if I work out in the afternoon, I would take my creatine after my workout, and then it's like right before dinner at like 5 or 6 p.m. And I would find I couldn't sleep as well. And so now I just have my creatine first thing in the morning, and that solved it. Other people don't have that issue. So there's obviously a little bit of personal experimentation that's required, but it does seem that creatine can be slightly stimulating, and because of that, it's offsetting some of the negative effects of sleep deprivation.
Okay. So it buffers energy. You talked about the two different studies, one being a lower dose, one being, I think you said the latter study was 20 to 30 grams.
Yeah.
Say you have a poor sleep and you want that benefit, how much will you take?
I generally take 10 grams a day. I don't manipulate that a lot. I just keep it the same because I'm more likely to just remember to take it and not worry about moving it up and down. There are creatine researchers, like I know I've heard Darren Kandau. He's a big guy in the creatine research world. He says that he'll take 10 grams a day, but then when he's sleep deprived or he's jet lagged, he'll take 30 grams a day. And that probably aligns pretty well with the research that we've seen. But I think when they do a 30-gram study, they don't necessarily compare it to a 10-gram dose. Whereas in that rugby study, they compared a standard dose, like a 5 to 10 gram dose, to a bigger dose. It was probably around 30 grams, and they saw the same effect. So we're still trying to figure out exact doses. Sometimes they dose it by just grams. Sometimes they dose it by body weight. In reality, it's hard to know how much of a difference you're going to get by increasing dose. But I certainly know people who feel they get more benefit on days when they need it with a bigger dose. Is that placebo? Is it because it's actually giving you more benefit? If you think it's giving you benefit, then do it, because that's probably going to be good for you anyway, because then you believe you'll perform better. So I think we're still kind of figuring out exactly what that dosing scheme might look like.
Okay, so for you, about 10 grams a day in the morning.
Yeah.
Have you heard about this talk about creatine and caffeine being competitive for absorption? And if you have it with coffee, not getting the impact of the creatine?
I haven't heard that. And
let me give you a bit more context.
Yeah, so
this isn't something I've dug into.
Sorry, there are different transporters in the gut. Like, they don't get taken up by the same transporters, as far as I know.
All I know is from one of my videos that's picked up a bit of steam. A lot of people are commenting under it the fact that you shouldn't be having the two together. But I don't know anything on the science about it, so I'm just curious.
Yeah, if somebody can send a mechanism like where they're competing with one another, I'd certainly love to see it. I haven't seen that. There are some data that suggest that once you get above about 10 grams, the creatine might start competing with itself for uptake. So the more you take, the smaller the percentage of that dose you're going to take up. So if you take 30 grams compared to 10 grams, yes, you'll take up more when you have 30 grams, but you might lose a bit more. You might have saturated the transporters, so some of that creatine just comes out the other end. So that's a possibility, is that with very big doses, you just don't end up absorbing it all. But I haven't seen the creatine versus caffeine thing. I don't think they're taken up by the same transporters, as far as I can tell, because they're quite different molecules.
Okay, we'll see what people say in the comments.
Yeah.
So given what you just said there about dosing, if somebody is sleep deprived and they want to use creatine to help with that, how would you space out the dosages if they want to hit, say, 30 grams in a day?
Yeah, so then it's probably, so in scenarios where you want to take bigger doses, and, some of the papers that we've published, we talked about creatine possibly after concussion. So then if you want to try and get as much creatine into the body as possible, then I would split your dose into like 3 doses of 10 grams a day, something like that.
The other thing I see in the YouTube comments is people talking about the kidneys and potential damage to the kidneys taking creatine. Any research showing that?
The reason why people think that is because of doctors who don't understand creatine physiology. And I can, I'm very confident in that statement, and I'll tell you why. So the reason why we think that creatine might damage the kidneys is because the most common marker of kidney function is a marker called creatinine. Creatinine you measure in the blood, and how much your kidneys reabsorb tells you something about how well your kidneys are functioning. So as your kidney function drops, so say if you have chronic kidney disease because you have diabetes, your creatinine will increase over time. Creatinine is produced as a byproduct of phosphorylating and using creatine in your cells. Every time you reuse a creatine molecule, some of it gets kicked out as creatinine. And so it accumulates in the blood, and the kidneys excrete it. as a result of that, creatinine is actually a much better marker of muscle mass than it is of kidney function. And you'll see as people get more and more muscle mass, their creatinine will increase because it's telling you about the amount of creatine and how that creatine is being used in the muscles. But if you start taking more creatine, your creatinine will increase because you've got more creatine and you're doing more with it and you're producing more creatinine as a result. Your kidney function has not changed at all. It's just a product of having more creatine in total in your system. And I've had like doctors and other people and clients be like really worried because their creatinine went up because they were after they started taking creatine. There was at least one study where they used a much better marker of kidney function called cystatin C. And you can see that when people take creatinine goes up and cystatin C stays much more stable. Cystatin C is also a better marker of kidney function because it doesn't correlate with muscle mass. It's actually telling you only about the kidneys, whereas creatinine is telling you about like 3 or 4 things at the same time. So people who don't understand all of that think that when creatinine goes up after taking creatine, that your kidney function is worse. But it's not true. And studies where there's at least one study where they've specifically looked at that, and creatine does not negatively impact kidney function. If anything, it might improve it slightly. Just because, right, your kidneys have more creatine and they need creatine for energy to do the work that they're doing. So no concerns about creatine and kidney function. And creatine is the most studied supplement of all time. Like sometimes I think like I'm too bullish about creatine. Like people will think that I think that it's a panacea. It's not a panacea. Of course, it's not going to fix everything. It's not going to magically prevent dementia or anything like that. Or it's also not going to make you like superhumanly strong. You've still got to like lift the weights in the gym. But they've done long-term studies giving high doses of creatine to frail older individuals, like people with Parkinson's disease, people with neurodegenerative diseases, and the side effects are very, very minimal, and certainly not including long-term kidney damage in people who are already old and frail. So I don't think that creatine and kidney function is something that people will have to worry about.
Okay, so you busted that myth, and it sounds like, in general, creatine's super safe. But are there any safety concerns with people taking, say, up to that higher dose of 30 grams a day?
Not that I've seen, but also not that I think people necessarily need to do that. There are studies where, in the majority of studies, you get most of the benefit, including increasing brain creatine content, improving mood. Right? There's now 2 or 3 studies where they've used creatine as an adjunct to treatment in depression. In all of those studies, like 5 to 10 grams a day is doing the trick. So I don't necessarily think that I don't think 30 grams, there's certainly no evidence that 30 grams is going to be detrimental. There have been studies like several years giving people 20 plus grams a day, seeing no negative effect. But I also think that most of the benefit probably comes at lower doses. So the only thing that you could say initially is that as you load creatine, so particularly if you start taking a high dose and you start getting as much creatine as possible into your cells, water does tend to move with it. So I have noticed some people feel a bit dehydrated when they first start to take higher doses of creatine, which is normal. That's just like water in the body redistributing itself with the creatine. So then if if on top of that you added a bunch of heat stress and sweating and all that kind of stuff, there's which people who are taking creatine and doing very heavy athletic type exercise and work, and they're losing a bunch of fluid, there's a slight possibility that could be an issue. But as long as you're making sure to hydrate properly, I think you can probably offset most of that.
All right, let's talk types, because there are a number of different types, and quality. What to look for in a quality creatine?
The simple answer is take creatine monohydrate and take CreaPure. The CreaPure is made by one company in Germany, and most supplement companies sell CreaPure. They just white label the same thing. They have a very standardized process. It's well understood. Your CreaPure has been used in most studies. That doesn't mean that non-CreaPure sources of creatine monohydrate are worse. But we just that's the thing that most people have used, and we understand it. I think the best thing that you can do is get a creatine monohydrate source from a company that does third-party batch testing. There are examples, so like Thorne has one, Momentous has one. These are companies who, right, they're not making the creatine themselves, they're buying it from somewhere else, but then they're sending it out to make sure it doesn't have stuff that you don't want in it. So that's the best thing to do. Creatine monohydrate is by far the best studied. There's an increasing interest in a supplement called guanidino acetoacetate, GAA, which is a precursor to creatine. And there are some studies that suggest that it can increase body creatine levels more than taking creatine monohydrate. But at this point, I'm not necessarily convinced that the sources are good enough quality that I would want to take it, and that it's more beneficial than taking creatine monohydrate. There's at least one study that showed that taking GAA increased homocysteine levels, which is like a marker of methylation, suggesting that maybe methylation isn't working as well as it should. But if you took regular creatine at the same time, that didn't happen. So if anybody's delving into the weird and wonderful world of creatine and they want to take GAA, you probably should take it with regular creatine. There are some supplements on the market that have that. I wouldn't take it myself. I don't think because creatine has been studied so well for so long, I'm not yet ready to jump on the new bandwagon because we just don't really understand it the same. All the other forms of creatine, crealkaline, HCl, all these other fancy forms, there's no evidence that they're any better than creatine monohydrate, and they're just more expensive. So I would just stick with what we know because we know it works.
Okay, so far we've talked on sleep deprivation, touched on the mental health piece, but what about brain health in general? And things like focus, reaction time, taking creatine, and even neural degeneration, things like dementia, being preventative for that.
There's certainly, there's more than one paper that's been written as a hypothesis that creatine could help to prevent cognitive decline. Because it supports, energetic status of the brain, which declines as we get older, and it declines in dementia. Again, right now, most of that is hypothetical. However, there have been a couple of systematic reviews with meta-analyses looking at what's the overall effect of creatine on cognitive function, particularly on memory. And it does seem to be beneficial, especially in those who are older and have already started to experience some decline. So while creatine probably isn't going to do a ton for your cognitive function on a day-to-day basis, if you're not sleep deprived and everything else is good, fast forward 20, 30 years, if you start to see some decline, then creatine seems to have a bigger effect. There are some studies in athletes that suggest that creatine can boost cognitive function even in healthy people. But just the overall burden of evidence suggests that the older you are, or if you've started to experience some deficit, creatine has more of an effect on cognitive function.
Let's bring it to performance, where creatine seems to have classically exploded. If somebody wants to use it for working out, what's the best timing with that? And then what type of exercise is it best for?
Yeah, so because of the way that creatine is used in the energy system, the shortest term energy system that we have is the phosphocreatine system, right? Then you have ATP produced through glycolysis, like anaerobic energy production. Then you have aerobic energy production through the mitochondria, in terms of speed of production. And the amount that you can produce, you can produce the least amount from the phosphocreatine system and the most amount, right? Essentially an unlimited amount from the aerobic system. So it's things that require very, very short-term, very fast energy production. So power and strength and sprint type workouts is where you're going to see most of your benefit from creatine, much less of an effect on long, sort of aerobic type work. So anything that requires explosive or very fast movement, you can, you're doing strength work in the gym, 3, 4, 5 reps. You can probably get, an extra rep with creatine, at least frequently enough that you're going to then start to be able to do more work. You can build more muscle and more strength. So that's the kind of work it seems to be particularly beneficial for. In terms of timing, there is a small amount of evidence that maybe taking it after a workout is better. But I think my interpretation of the evidence is that difference is probably so small that for most people, it doesn't really matter. And the reason why I say that is it's the best time to take it is the time that you're going to remember to take it and take it consistently. And, if it is stimulating for you, that it doesn't negatively affect your sleep. So the reason why I take it in the morning is because I just set out my morning supplements and then I take them and then I don't need to think about it. So if you prefer to have it in your pre-workout shake or your post-workout shake or in the morning, I think the most important thing, or you get the most benefit just by taking it consistently, the timing in the day is going to matter much less.
Unless we find out in the comments that it competes with caffeine.
Yeah, well, send me the papers. Unless I see the paper and understand the mechanism, then it's just hearsay.
As you're talking about these different benefits, including putting on muscle because we can have a better output in the gym, the cognitive benefits, to me, it's shouting out the fact that as people are aging, this would be such an important supplement as their cognition is naturally declining and muscle mass is declining.
Yeah, there has been a bit of work in that arena, at least from the cognitive function side. And then there was one big randomized controlled trial where they gave creatine 20 grams a day to postmenopausal women as part of a resistance training program. It did seem to maybe help improve some aspects of bone structure, when added to a resistance training program. But in that setting, like getting in the gym and doing the work is the most important thing. So I think part of where I would put this in the framework is that maintaining physical function and maintaining brain function, the most important thing is that you challenge those systems, right? You get in the gym or you do some kind of you don't have to be doing heavy deadlifts and whatever competing in powerlifting competitions, but resistance training, doing resistance to put mechanical tension on your muscles. That is what helps maintain muscle mass and bone mass as you get older. And the same is true for the brain. If you want to maintain cognitive function, you need to keep doing cognitively challenging things that then drive function. If creatine helps you to do that, right, it helps you get in the gym and work hard. It helps improve your focus slightly so that you can go and learn a musical instrument or go and have a stimulating conversation with somebody, then I think it's going to be beneficial. If you don't do those things and just sit at home doing nothing, taking creatine, it's not going to do that much. So if it enables you to do more work that stimulates function, great. But it's like on its own, it's not magic.
What about on the other end of the spectrum, kids? Has there been any research done on, below 10 kids taking creatine and any benefits there?
There's some studies in youth athletics, so maybe tweens and young teens. I don't think there's a ton in very young kids, except for in the world of pediatric concussion. Actually, probably some of the best evidence, and it's still quite small trials, but some of the best evidence that creatine can be beneficial after a concussion comes from a pediatric, childhood concussion study. There are some review papers out there that suggest that taking creatine when you're younger is perfectly safe. Certainly no reason to be concerned about it. But I will say that there are also position statements from some pediatrics groups that say that kids shouldn't take creatine. So I'm not gonna delve in there. You listen to the people that you need to listen to in that scenario. Because creatine is just it's a natural component, particularly of meat and fish, which, the kind of, to put stuff in context, the amount of creatine. So if you take 5 to 10 grams of creatine, that's a couple of tins of sardines, right? it's not, well, depending on the food, it's potentially easy, right? If you slammed back a few tins of sardines, you could get 20 to 30 grams of creatine. Like, people might not want to sit next to you, but the amount of creatine that we're talking is possible to get from the diet, which is why I think we can be confident that it's pretty safe. If you wanted to get that amount of creatine from beef or salmon, you're going to have to eat several pounds of it in a day, which some people can do and some people do. So, right, if you're eating that much meat, you probably don't need to supplement with creatine if that's the diet that works best for you. So, one of the reasons why I'm not super concerned about specific groups taking creatine is because this is a level that we could get from the diet if we wanted to. It's not easy, but it's possible. So I think that kind of speaks to the safety range. Again, if people are thinking about it, and particularly when you're doing stuff in kids, and this is for everything. If drugs, any supplement, any intervention. And again, not suggesting that kids will have to be hosed down with creatine, but you then have to start thinking about dosing by body weight. So if you're going to do that, figure out a sort of like a safe calculation that makes sense in that case. Just because kids are much smaller, they're going to need a lot less of whatever it is we're talking about.
So it's found in animal products.
Yeah.
Is it found in plants at all?
Not that I know of. Certainly not in the kind of doses or contents that we're talking about.
Okay, because I've heard of a story, and I don't have the paper or anything, where it was either vegans or vegetarians taking creatine and having a mental boost from that. And obviously that makes sense with everything you're talking about. And the fact that likely it's not even in plant products and it has all these benefits that we've been sharing. Have you heard about that paper I'm referring to?
Yes, but equally, people who are on omnivorous diets that eat meat also seem to see benefits from creatine. So it's probably most of us, regardless of the diet that we eat, are probably not consuming a lot of creatine unless it's a lot of meat and fish, which some people eat, but most people don't. That's not where the majority of their calories come from. The other part of this that potentially plays a role is the methylation system. So making creatine is it's like, if you're thinking about methylation as like the moving of methyl groups around things that like activates genes, it activates proteins and cells to do, like it's a really important way that we regulate metabolism is methylation. And it requires several B vitamins, B12, folate, B2, and B6 are the four main ones that are needed for methylation. And the majority of our methylation is used to make creatine. That's what we invest a lot of our methylation in. So people who are deficient in B vitamins required for methylation, or for some reason, right, their methylation system isn't working as well, they may get more benefit from taking creatine. This is entirely hypothetical. I've thought this. I haven't seen a study that says it, but it just kind of like, it makes sense based on what we do to make our own creatine, which we do constantly. So the reason why I say that is because some of the B vitamins that are critical for methylation are less found in plant-based diets and should be supplemented with if you're on a plant-based diet, particularly B12. So it could be like this knock-on effect, which is not that it's not because you're not eating enough creatine from your diet. It's that the creatine is helping offset a relative insufficiency of a B vitamin associated that's required for methylation. Does that make sense? So like that's one reason why people on plant-based diets may anecdotally see more benefit from creatine is if there are other vitamins in that system that they need more of.
If all the nutrients are in place and the body can make what it wants, creatine-wise, do we know how much it'll make in a day?
Great question. I'm sure somebody does, but I don't.
I'm just curious if it's around the 5 gram range and we're adding another 5 with supplementing or what.
Yeah, that's a very good question. I don't know the answer to that. Maybe somebody can put that in the comments and then you can tell me.
We're going to be busy in the comments. Thank you guys. Let's move into another supplement that is gaining a lot of momentum when it comes to brain health and beyond, methylene blue. And there is so much controversy around this one. A lot of people loving it, a lot of people fearing it because it is synthetic, and there's even talk of making the brain blue by using it. I've experimented. I'm a fan to this point, but I do want to learn more. Talk about what you've learned and what research is showing.
It's funny because methylene blue does accumulate in active neurons. It originally started as a dye that could be used for a dye in the nervous system. So it can actually, or at very high doses, it could turn your brain blue. For most people, that's not the thing that you need to think about. But it's just like, it is technically true, and that's part of the history of methylene blue. I think it's interesting, but what is particularly interesting to me is that the evidence is pretty thin. Like there aren't really good studies. So say you take a group of people in their 60s and you give them some methylene blue or a blue placebo, and you measure like various aspects of their cognitive function. Those studies exist for creatine. They do not exist for methylene blue. And the best evidence for methylene blue is very high doses, like 1 to 4 milligrams per kilo, right? So we're talking potentially hundreds of milligrams in a setting of acute hypoxia. So now we're talking about like, if you were taken and dumped on the top of Everest, or you're a fighter pilot at, tens of thousands of meters above the earth, right? In those settings, so if you do acute hypoxia, methylene blue seems to maintain some aspects of blood perfusion to the brain and some aspects of cognitive function. But that's like one study. For like day-to-day people taking methylene blue, there's very little good quality evidence that people should take it. Now, theoretically, it's been proposed in Alzheimer's disease and like in some animal models of impaired like metabolic function in the brain, which is part of the picture of some dementias. It seems to restore function. And it's because it can help to improve ATP production in the mitochondria. Now, the problem is that depending on where the deficit comes from, like the theoretical deficit that your methylene blue is overcoming, it may or may not be a good thing, because if your mitochondria are already performing well, methylene blue can make them short circuit and perform less well. So I know a lot of people who use methylene blue, who recommend it to clients, who say they've seen benefit. So I believe that there are people benefiting from it, but like, do a study and send me a paper, because right now, almost all of it is anecdotal. And even when I talk to people who sell methylene blue, like have methylene blue products and like are big believers in it, and like, I believe them. I believe them to be, truthful and dedicated researchers and physicians. Those studies don't exist. I'll tell you that when I take methylene blue, like a standard, like 4 milligrams small dose, my cognitive function tanks. I feel terrible, like particularly in word finding. Like I just cannot get words out of my mouth. Like my brain just doesn't work well. So, and again, this is anecdotal, right? This is all just like, I tried this and I feel this. I don't have, I didn't measure anything. That's just how I feel. So, I think that there's probably a subset of people where the mechanism makes sense and it could help. I think there's also a subset of people where it could be detrimental, and there's a subset of people where it's not going to do anything or very little. But right now, I can't tell you who is who in that. There are people who say that they can do that, and there are some people who are developing tests that say that they can tell you whether methylene blue will work for you or not. But again, like that research doesn't exist. So it's all based on mechanism and a hypothesis. So it's interesting, but until like some people actually do some high quality work in humans, it's not something that I'm going to regularly recommend.
So it sounds like it, because of your experience with low dose methylene blue, You've tried it a handful of times. It's decreased your performance.
Yeah.
So you've pushed it aside, at least for now.
Yeah, for me. And like, that doesn't mean that other people shouldn't take it, but having also tried to look for good quality research on methylene blue and cognitive function that's relevant to most people, but it doesn't exist yet.
What about nicotine? This is another one when it comes to the brain cognition. It seems like more and more people in our world are using it as a nootropic to, stimulate word finding and cognition. How do you feel about it?
Yeah, we're probably, in the world of nicotine, we're probably a little bit closer to methylene blue, but like on the scale of like, because we talked so much about creatine, we have creatine one end, methylene blue at the other. Like nicotine is like close to methylene blue, but like on the way to creatine. Like everything about like the evidence and that kind of stuff. I think there is some interesting evidence for nicotine potentially in neurodegenerative disorders. So one of the things that gets lost in Alzheimer's disease is acetylcholine signaling, right? And that's where like nicotine binds to those receptors in the brain, could help with memory formation and retention. So there are some scenarios where it could be beneficial. So one of the reasons why one of the first drugs that people get prescribed for Alzheimer's disease is a cholinesterase inhibitor that prevents acetylcholine being broken down. I think we have much better evidence for that than we do for just like sticking nicotine patches on these people. So like that's where I would focus. But there are some small studies that say that nicotine can improve some aspects of cognitive function. The problem, this problem is also relevant to caffeine, is that it's slightly addictive and and you get withdrawal symptoms. So, anytime you become dependent on something like this, you create potential problems. And especially in the modern world, like before, right, you wanted to get some nicotine in your system, you had to smoke it. Like now there's like a million ways to get it in the system, and there's like you can get a lot more nicotine than you ever could previously. And I think that's causing big problems, and especially the route that you get it, that's causing a lot of problems. So there are certainly some people who say they benefit from small doses of nicotine, like a milligram, like they chew it in a gum or something like that. They feel like their brain performs better. I'm not going to say people should or shouldn't do that, but in the bigger context, it is habit forming, does cause withdrawal symptoms. You just have to balance that with your other priorities.
So now we've gotten into the weeds with a lot of these hacks: methylene blue, nicotine, creatine. What was the other one? We had one more.
Caffeine,
that's the one. So I want to come back and go more high level and talk about diet to support our brain.
There are 3 levers that I like to talk about. Everybody likes to like have their levers or pillars or whatever. So I have 3. And so the first is basically maximize the nutrient density of your diet. If you think about the process of generating and sending a signal in the brain, which is happening in billions of neurons constantly in your life, you think about the coordination and the nutrients required to do that. It's essentially like, it's mind-boggling. You just can't even understand how it's even happening. But it's everything from iron, vitamin D, omega-3s, all those B vitamins that we talked about, magnesium and zinc, because they're neuromodulators that get released with neurotransmitters, choline to make acetylcholine, like all the amino acids that are the precursors to things like serotonin and dopamine. All of these things we need to get from our diet. So the best likelihood of us achieving that is having a diet that's as nutrient dense as possible. And in general, that is a diet that has high quality, minimally processed animal and plant foods, like antioxidants, lutein, zeaxanthin, anthocyanins, and other polyphenols from berries, and coffee and tea. These all have been found to be beneficial for long-term brain health in various different ways. So a diet that looks like a whole foods based and minimally processed diet is the one that's the most nutrient dense. If if you don't have a diet that is as nutrient dense as you want it to be, then I think we're seeing more and more evidence that people, a multivitamin can help. So the Cosmos trial recently showed that. And then they also had an arm of the Cosmos trial that included cocoa flavonols as an antioxidant. And that was beneficial in people who had low antioxidant intake in their diet in general. It wasn't beneficial for everybody, but like if you're not eating berries and fruits and vegetables and things that have these sort of like colorful type antioxidants, then it seems that like a flavonoid supplement could be beneficial as well. So the nutrients is the thing that I like to focus on the most, because if you get the nutrients, it doesn't really matter where the nutrients come from, right? Then we don't have to argue about keto versus plant-based versus paleo versus carnivore. Like, just get the nutrients that you need, and that's it. As long as, which is the next lever, you consume enough total food. So for most people, overeating and entering into energy excess, insulin resistance, that's most common in modern societies. So what's good about sort of like a whole food type diet is that it's much harder to overeat it and end up in energy excess. And what's interesting is that you can see, like, looking across societies across the world, including the US and Europe, but also hunter-gatherer type groups, what you see is this inverted U-shaped curve of energy intake and brain, like how much brain you have. And brain volume is a critical predictor of long-term brain function and brain health. So at low energy intakes, so either think, people who, tribes where they just don't have, hunter-gatherers who don't have access to much food, or you're a subsistence farmer and the crop fails, or you're some like calorie restriction obsessed longevity person, you're at low energy availability. That's associated with lower brain volume. Because if you don't have the energy to support that brain, you're not going to maintain that brain structure or build it in the first place. Then brain volume increases as energy availability increases. So in that scenario, the more you eat, the better. More calories is better. You've got more energy to support a bigger brain. Eventually, at some point, you enter this tipping point of energy excess. And that's where we start to see, that's why obesity is associated with long-term cognitive decline. It's why prediabetes and type 2 diabetes are associated with faster cognitive decline and more dementia. Metabolic syndrome, anything in that picture, then brain volume starts to decrease again. So that is like the next lever, is you need enough energy, but not too much. And then the reason why I talk about like nutrients and then energy is then like how you achieve that is through like your overall dietary pattern, right? And so like the pattern answer I already gave you, which is, ideally a minimally processed whole foods based diet. But if you're an athlete who has very high energy requirements, maybe that includes a ton of processed food just so you can get enough calories in, right? I've seen that a bunch as well. So then their pattern has to be different because they have different energy requirements. So the way I think about it is you take your nutrient needs and you take your energy needs, and then you use that to figure out a dietary pattern that best provides both of those. And as long as you do that, where that energy comes from and where those nutrients come from, I'm completely agnostic to it.
The part I really want to hone in on is this uniqueness of the brain, at least the way I understand it, where it can burn glucose, it can burn ketones, but fatty acids, not so much. And this ties into the whole metabolic health piece. And I want to go deeper into that with you, where if somebody is metabolically unhealthy, which is most people these days, unfortunately, they might run into some problems with brain energy. So to start, can the brain burn any fatty acids, or is it just limited?
So it can burn some fatty acids, but only ones, and this is something that there was actually a very recent paper that kind of expanded our understanding of this. Do you see the paper on like white matter shrinks in marathon runners?
No, I didn't.
So
I want to hear about it though.
Yeah, so they took 10 marathon runners in Spain, and they scanned their brains before and afterwards. And what they saw was that the white matter which is where the myelin, all the like most of the fat in your brain, and your brain is mostly like the non-water content of your brain is majority fat. And most of that is in myelin, which wraps around and protects neurons in the white matter. So it allows for fast connection through the brain and to the body. And what's unique about human brains is they have more white matter than any other species. So like a rodent is 5 to 10%, a human is more than 60% white matter. And what they saw was that from like before and after the marathon, the white matter shrank in these marathon runners, but it was reversible. So like 3 months later, they'd restored it. But the idea is that in a significant energetic stress, which a marathon is, right, you cannot consume the number of calories that you need to do a marathon during a marathon. So because the brain isn't getting as much energy as it needs, it will start to eat itself, and it will use fatty acids within the brain to help support it. And then that recovers just fine. And like, it's not a problem. There's no reason to think it's bad, but it's just that was evidence of the brain using its own fatty acids for energy. But the brain does not take up fatty acids from the blood for energy necessarily. Most fatty acids and cholesterol in the brain are synthesized locally and from glucose or ketones. So particularly during brain development, all the fat or the majority of the fat and cholesterol that accumulates in the brain when it's first growing are synthesized from glucose and ketones. And actually ketones are preferentially used as a synthetic precursor in the developing brain. That's why breast milk contains medium chain triglycerides, which the baby turns into ketones. Ketones go into the brain. Brain uses the ketones to build things, including fat, cholesterol. So in general, the answer is no. The brain doesn't take up fatty acids from the blood specifically to burn them for energy, but does take up glucose or ketones or lactate if lactate is available from exercise. And so you're right that as your people become metabolically unhealthy, or they become insulin resistant, there does seem to be this link then to cognitive decline and dementia. So I already kind of mentioned that there are studies that look at cognitive decline over time. And in people who have normal blood sugar control, so they have an HbA1c below 5.7, which is what they used in this study, then they looked at people with prediabetes, so above 5.7 up to 6.5, so prediabetes, so they have higher blood sugar. They had faster cognitive decline, and then it was even faster in people who had type 2 diabetes, so even worse insulin resistance and blood sugar control. And then there's also evidence, or like one of the ways that you help to diagnose Alzheimer's disease in particular is that glucose uptake into the brain declines over time. So you can measure glucose uptake into the brain using something called a PET scan, and you can see, there's not as much glucose going into the brain here. Some of it seems to be related. So if you have metabolic disease, it's maybe impairing glucose uptake into the brain. But the other side of that is also that, particularly in the early stages of cognitive decline, the brain will take up more glucose, but it has to ask for it. So some of it is demand driven. Like, we're not using our brains, so our brain then isn't asking for glucose. So it's not necessarily that the glucose can't get in. It's that the brain isn't asking for it. And there are studies that show that if you stimulate the brain with a cognitively challenging task, it will, like even in early Alzheimer's disease, that glucose will get in. It just, the brain needs to ask for it. So this is why when I said earlier that demand is what, like stimulus is what's really critical, that stimulus is what drives some glucose uptake into the brain. But yes, in general, one of the biggest risk factors for dementia in the modern world is some kind of state of energy excess or insulin resistance. And it probably, the downstream effect is either through impaired glucose uptake, higher levels of inflammation, higher levels of oxidative stress. It's then impairing energy production in the brain, which then creates or helps to precipitate cognitive decline.
In a classic sense, insulin resistance is when somebody is consuming more carbs or sugar, spiking blood glucose, and then insulin comes in to drive that into cells. And over time, the body becomes resistant to that insulin, and that system isn't working well. A, is that how you see insulin resistance? And then B, let's take it to the brain, because we do have the blood-brain barrier there. And you've touched on this, but I want to make sure I understand this piece, because so many people are affected by this. And I could see how it could affect things like just cognition day to day, dementia, mental health challenges, when energy isn't getting to the brain like it should be.
This traditional idea that eating lots of carbs, that spikes lots of insulin, and then that causes insulin resistance, in and of itself, I don't think that that's actually what's happening. Because there are plenty of people who eat lots of refined carbohydrates, they spike their insulin all the time, blood sugar comes down, they're fine, they never develop insulin resistance. It's much more to do with the chronic overconsumption of calories that then messes with your insulin signaling system. So as you accumulate excess energy on your body, initially as subcutaneous fat and then as visceral fat or fat, fat around your organs or fat in your organs, like fat in your pancreas or in your liver, what happens is those cells those cells then don't listen to the signal of insulin because there's already too much energy in them. So insulin's main job is not to shove glucose into cells. Actually, you need a little bit for that to happen. And the reason why we think that that's insulin's main job is because of type 1 diabetes, where if you don't have any insulin, no glucose gets into cells and you get in trouble very quickly. But most of us just have like a small amount of insulin and it goes around the body and it opens the gates and glucose gets in just fine. Like most of the glucose uptake in our body is demand driven, like I mentioned in the brain, but also in muscles. So most of the majority of the glucose in your body is taken up by your muscles, and the majority of that is based on the activity of the muscles. So if those muscles aren't moving, they don't ask for the glucose. It's not that the glucose can't get in. In fact, particularly in early prediabetes and type 2 diabetes, there's lots of glucose going into those cells, but it's not being used. And that's the problem, is that the energy is not being used on the back end. So it's actually this overaccumulation of energy substrates, either in the fat tissue or in other tissues, that are not being used, that then impair insulin signaling. And they sort of shut down insulin signaling by saying, we can't take any more. And the next step that's the problem here is that what insulin's main job is actually to shut down the release of energy into the system from muscle tissue and fat tissue. So it inhibits proteolysis, which is the breakdown of muscle tissue to release amino acids, and it inhibits lipolysis, which is the breakdown of fat tissue to release fatty acids into the body for energy. So when you become insulin resistant, because those tissues already have so much energy in them, what happens is they start to spill out. So you have a very high turnover in the fat tissue that essentially dumps a bunch of fatty acids into the system, because insulin can't do its job. It can't hold it in like it's supposed to do. And then when you have too many fatty acids in the system, that's when you then start to see liver impairment and all these other issues. So insulin's main job is to regulate how much energy is circulating in the system. And when tissues become insulin resistant because they have too much energy inside them, you then get too much energy as glucose and fatty acids circulating in the body, which then causes those downstream issues. So it's a slightly more nuanced picture of what insulin does, but its main job at the normal levels that get released after we eat is to stop the breakdown of tissue, stop fat being released from fat tissue, stop glycogen being used, stop muscle tissue being broken down. Because then when we're not eating and we need that energy, insulin drops, they get released into the system and the liver turns those things into glucose to be used. So that's its main job. And when those systems already have too much energy in them, insulin can't do its job, and we end up with this sort of energy toxicity, too much circulating around the body. Sorry, that was a really long answer to your question, but that's kind of I think about insulin a lot, or at least I have done over the years.
Let's bring it back to the brain, and you've touched on this, but I want to make sure I have full clarity here. Let's talk about, as somebody's becoming metabolically unhealthy, all the different components here in the brain. And we've already talked about the fact that fatty acids can't get in there well. And you've just clarified some nuance there when it comes to insulin resistance. But basically, why I want to go here and make sure we have full clarity is so many people are affected by this. And I want them to understand, if they're in this boat, how it could be affecting their cognition day to day, and then potentially lead to things like mental health challenges and dementia.
Yeah, you mentioned the blood-brain barrier earlier. And one role of the blood-brain barrier is to make sure that our brain is protected from all the other stuff that's circulating around in our blood. There are a few parts of the brain where there's less of a strict barrier, but for most of the brain, it's very highly regulated, including energy getting into the brain. And when you start to enter this sort of state of energy toxicity, as you could call it, you start to see, first of all, an increase. Right, one thing that we know that happens is an increase in inflammation, an increase in oxidative stress, because like the system can't handle all the energy that's circulating, and both of those are very closely tied to issues with, say, depression and anxiety. Right, inflammation seems to be a driver in some significant proportion of people with depression. It's not everybody, but it seems to be a significant contributor to a good chunk. I think some people have said like a third of depression seems to be sort of inflammatory driven, and oxidative stress similarly. So these things impair the function of the mitochondria, but also impair the function of the regulating or sort of resident immune cells in the brain, like the microglia. If anybody have heard of those, the microglia are essentially our brain's version of an immune system, and chronic inflammation or oxidative stress can make them angry. And it's the microglia are the most complex cell in the body by far. There's like thousands of different versions of them and different jobs that we still don't fully understand. So I'm painting very broad strokes here, but in general, they're really important for monitoring synapses, helping repair injury, some parts of signaling. And in this setting of chronic inflammation, they can then start to essentially accelerate that. You make a microglia angry, it increases inflammatory processes, it can increase the breakdown or issues in communications with neurons. So that's probably a big part of it. And that, like you say, when we're thinking about contributors to dementia and cognitive decline, inflammation and the way energy signaling and the way that it interacts with both like the function of neurons, but also cells like the microglia, seems to be a significant proportion of what's contributing to cognitive decline. It's not necessarily just through energy availability. It's also through like what are the downstream effects, like inflammatory processes that then have a knock-on effect on multiple parts of the brain. So there's another bit that we haven't really talked about, which is very relevant to this scenario, which is the health of the blood vessels. So as we have chronically elevated blood glucose or blood pressure, or anything else that contributes to poor cardiovascular health, one of the things that people don't necessarily appreciate about the brain is that it's essentially this really, really dense network of blood vessels with a few neurons thrown in. Like if you took away all the other cells in the brain, you would see this really dense sort of structure of blood vessels that the kind of like all the cells are kind of impregnated into. So really the brain is this massive vascular network, and then that kind of runs the whole system. And so when a certain part of the brain becomes active, it asks for more energy. There's this thing called neurovascular coupling. And then that part of the brain delivers more blood flow. It starts to divert blood flow to that area. If you don't have healthy blood vessels, that can't happen. And we know that endothelial function and blood vessel function declines as we become less metabolically flexible or less metabolically healthy over time. So yes, there's effects on energy availability, there's effects on inflammation, how that affects the cells in the brain. And then there's also, are you impacting just the ability to get oxygen and nutrients to those parts of the brain because of a healthy vascular system or not. And that's where like metabolic health we know is very tightly linked to cardiovascular health. So that's a big part of it too. And when you look at something like Alzheimer's disease, most people who have Alzheimer's disease also have vascular disease in the brain. Like they're not, for most people, it's not separate entities. Like it's the same, it's part of the same disease process. We, as neurologists and neuroscientists, we like to classify things into these nice little buckets. But actually, particularly vascular dementia and Alzheimer's disease overlap very tightly. And I think for most people, they're probably part of the same process. And some of that is deteriorating function of the blood vessels, which we know is very tightly linked to metabolic health.
Let's bring ketones in now in the ketogenic diet, because a lot of what we've been talking about now can be helped or remedied with that diet. The energy getting into the brain, we have ketones now. The metabolic dysfunction and the effects on the vessels, the inflammation. So to me, why I'm such an advocate for discussing and sharing this diet and actually consuming it myself is because of all these different reasons. And for the general population, people that are metabolically unhealthy, which again is 90+%, this can be such a powerful tool, at least in the intermediate, to regain metabolic health. So share your thoughts on that.
I've been a big supporter of low carbohydrate and ketogenic diets for a long time in certain scenarios, and certainly we have a lot of people in the psychiatry space who are showing that ketogenic diets can be helpful with bipolar disorder, schizophrenia, depression. You have guys like Stephen Kinane showing that MCT oil could help improve certain aspects of brain energetics in cognitive decline and maybe early Alzheimer's disease. And some of that does seem to be that ketones are more readily crossing the brain and providing an energetic substrate to the brain. Some other parts of it could be because, like I already mentioned, that ketones are a preferred synthetic substrate. So if your brain is trying to repair itself from something, actually those ketones might provide the building blocks in order to do that. That's one reason why I think ketones could be beneficial after traumatic brain injury or concussion. There isn't a ton of evidence for that yet, except for in animal models. There isn't great evidence in humans yet, but I think like theoretically it makes sense. So there are scenarios where ketones do seem to be able to rescue some aspects of cognitive function or mental health. It does require, I think, a bigger picture, though, because one of the reasons why any restrictive diet, and here you're restricting carbohydrate, is like you decrease the amount of energy, the total energy in your system, right? So any diet that sustainably allows you to decrease calorie intake, I think is going to have a lot of these same benefits, because a lot of it's stemming from essentially energy toxicity. So there are other studies where people go on a whole food plant-based diet with early cognitive decline, and they see benefit. And I think across both groups, what you're seeing is you just eat, you're already energy overloaded, and you're offsetting that and starting to come back from that because of the changed dietary pattern. So yes, ketones have a special role, but for most people, the issue is energy overload and energy toxicity. And the easiest way to do that is whatever diet allows you to enter into a calorie deficit. So I'm definitely a proponent of ketogenic diets when used in the right setting, but I don't think that they're like the prescription that everybody needs, because I think the main issue is energy toxicity. And so I'll give you another example. There was a recent very large randomized controlled trial published in the New England Journal of Medicine, like the world's top medical journal or one of the world's top medical journals, where they compared a Mediterranean style diet, the MIND diet, which is a sort of a nutrient-dense Mediterranean-style diet specifically focused on brain health. It's like a combination of the DASH diet and the Mediterranean diet. They compared that to just standard calorie restriction, both groups saw significant improvements in cognitive function, and both groups lost the same amount of weight, and improved their body composition in the same amount. So even though one diet, I would have put all my money on the Mind diet, more nutrients, less processed, all that kind of stuff. But in that setting, the most important thing was decreasing energy intake, that's the scenario that most of us are in. So I am really excited about work on ketogenic diets in psychiatric disorders. I'm really excited about ketogenic diets and the research in concussion, traumatic brain injury. But for most of us, the diet that's gonna work is the one where we can sustainably decrease calorie intake, because like that's where the biggest stress is coming from the brain. And yes, ketones might help offset some of that in some populations, but I think the main problem is just our total energy intake.
What's your current diet like? And do you ever dip into ketosis to provide that alternative energy for your brain?
So I have been low carb and keto, tried carnivore. I've tried paleo for a while. I was plant-based for a while. I've tried them all just to kind of like see the effects. Essentially, I kind of eat what I said, which is a minimally processed, whole foods, nutrient-dense type diet. So I eat meat. I eat a lot of veggies. I don't eat a ton of starchy carbohydrates like rice, bread, cakes, cookies. I don't eat a ton of desserts. It's mainly like meat and veggies and fruit. And like certainly some grains. I'll cook pasta occasionally, cook rice occasionally. Sometimes I'll make a pizza. Like I'm not strict. I'm not like strictly restricting carbohydrates. But I work with I have very good friends who are military vets who had several concussions, and they're like, my brain only works when I'm in ketosis. So I've certainly seen that work for some people. But my main focus is, am I getting enough energy to fuel my workouts? And am I getting all the nutrients that I think my brain needs? And the way I do that is just minimally processed sort of whole foods. But I don't like particularly, I restrict kind of really energy dense carbohydrates from like a processed food standpoint, but I don't restrict carbohydrates in general, if that makes sense.
You mentioned Stephen Cunnane and MCT oil. For yourself and others, how do you look at things like C8, C10, MCT oil, and exogenous ketones to provide that keto source of energy for the brain?
Again, so I advise a couple of companies that make these things from like a scientific standpoint. I don't make any money from it because I'm excited about their potential applications. The problem that I've really seen in this arena is that there's so much hype and very little really good quality science. So there are some groups like Jonathan Little's group up at UBC. They've done studies of ketone esters in type 2 diabetes and obesity. In like some of their studies, it seems to improve cognitive function. In some of their studies, it doesn't. Like I said, in like specific clinical scenarios, they're just the Stephen Cunnane's studies with MCT oil in people with early cognitive decline. But again, there's just so much where people are saying this is the answer, but those studies still haven't been done yet. So it's not something that I widely recommend, because I can't say in this scenario I think this is going to be beneficial for you because that study hasn't been done. So I know there are lots of people who anecdotally feel a lot better, when they take MCT oil, they put it in their coffee, or they take ketone esters. There are certainly some potential like performance applications, and again, just now some of the best quality studies are being done, like by my friend Andrew Kutnick, who's at the Sansom Institute. They've published some studies on ketone esters in like hypoxia and exercise in military scenarios. And again, like sometimes there's a benefit, but sometimes there isn't. So when people are actually doing high quality studies, it's a little mixed. Like sometimes you kind of say, oh yeah, this is doing what we think it's doing, and sometimes it's not. So like I said, I'm a believer that we will find the right scenarios where these things will be beneficial. But I'm still waiting for the research for me to be able to just say, oh yeah, we need to put ketone esters in the water supply or something, which other people, I think at one point, Richard Veach, who was the inventor of like the original ketone ester that most studies still use and groups still use. I think at one point he said we should just like put it in the water supply. I'm still waiting for the study that convinces me that that's the case. So I'm a fan of these things. I don't think the research is there yet in the way that I would want to see it.
Last question for you. Fasting. Shorter and longer term fasts. Connect those to brain health.
The main way that I think those are going to improve brain health, again, is through like manipulation of overall energy availability. When you look, so most of what we've been sold on the effects of, let's say, like intermittent fasting on health has been done in mouse studies. And in mice, intermittent fasting, like not eating for several hours in a day, in mice, that's a big problem. Like a mouse doesn't eat for 24 hours, it dies, right? Fasting in mice is a huge energetic stress. And that's what drives a lot of these adaptations. Fasting in humans is not a huge energetic stress. You could survive several days without eating. Like you wouldn't enjoy it necessarily unless you've kind of gotten used to prolonged fasting. But it's not driving these same adaptations in humans that it's driving in mice, because it's not nearly the energetic stress that it is in mice. So an example of this, again, another colleague of mine, Christy Storashuk, she recently published a systematic review and meta-analysis looking at the effects of fasting on muscle tissue and mitochondrial function, like the signatures of mitochondrial biogenesis. People have talked about PGC1 alpha, and this stimulates mitochondrial biogenesis, and we stimulate that when we fast. And there are reviews in very fancy journals that say that this is the case. And when she looked at all the literature, that effect in rodents, it did happen in some studies, but not in others, and it does not happen in humans at all, because fasting just isn't that kind of stress to the muscles of humans. So I think that some of these benefits of fasting are possible at very extended fasts, but in order to do that, it has to become a significant energetic stress, like it is in mice. So we're talking several days, really prolonged fasts. If you're thinking about some of the downstream effects of fasting, so like autophagy is the one that we hear about a lot, right? You're turning over junky proteins and cells. And the fastest way to stimulate autophagy in humans is exercise, and aerobic exercise. So you can fast for like 24 hours. You won't see any autophagy in many cells in the body. As soon as you start exercising, you're going to start stimulating autophagy. And we do have to extrapolate something from mouse studies, because I can't measure autophagy in your brain after you do a workout. But when you stimulate autophagy in other animals through exercise, you stimulate autophagy throughout the body. So I think that fasting is a great tool if it allows, if you need to decrease your current energy load, your calorie load, and fasting allows you to do that. That's great. Like if manipulating your diet or going keto is not for you, but you can just not eat for a day and that works for you, great. But it's mainly working by decreasing overall energy load. And then if you want to upregulate some of these longevity processes that are supposedly associated with fasting, the easiest way to do that is go for a jog. So that's what I would do. Whatever dietary pattern allows you to, best control energy intake so that you don't enter into, or you start to reverse some of the effects of energy excess, insulin resistance, metabolic disease. And then to actually stimulate the processes that we think about with fasting, do some exercise. And there's a nice quote from Bill Lagarkos, which is that exercise is fasting and fast forward. And essentially that's kind of how I see it too.
All right. Earlier you mentioned you're working on a book. Any idea when you're going to complete that and when we'll see it on shelves?
I've been told not to promise that because then people will be frustrated when it doesn't come out when it's supposed to. So watch this space and I will let you know as soon as I have a date.
All right. Thank you, Tommy, for coming on. We're going to link up your social media, your website, everything in the show notes. Thank you.
Thanks so much. This was great.
Now that you're done, you're going to want to stick around here and catch this other incredible episode. You don't want to miss it. I'll see you over there.
It has been shown since the 1980s that insulin resistance, basically a problem with glucose uptake in the brain, is a big problem for people with Alzheimer's disease. And this is true for many other neurodegenerative disorders.